Hi guys. If you have not finished watching the National Geographic video on colliding continents, you should do that before you begin your notes. So please hit pause, finish the video questions. When you are finished with those, you need to turn those in. Okay, so let's get started on today's work. I'd first like to review our content statement, and that is that Earth's crust consists of major and minor tectonic plates that move relative to each other. If you remember, we talked about the fact that if you took the globe and made that into a puzzle, okay, the surface of the Earth would be made up of many pieces that fit together, okay, and we call those pieces tectonic plates. Okay, so our learning goals for today. After your notes, you should be able to state and explain evidence for the hypothesis of continental drift, meaning tell me, what did they think? Why did they think that the continents drifted across the oceans? And second of all, you should be able to explain the difference between plate tectonics and continental drift. We kind of got a start on that already with the exercise we did the other day. So I hope today clarifies any points that you might have, or any questions that you have about the material. Okay, so here we go. Continents drifting apart. So I know it's kind of a corny joke, but just looking to make you laugh early in the morning or late in the afternoon for fifth period. Okay, so let's first talk about Alfred Wegener. 1915 was when he published The Origin of Continents and Oceans. We mentioned in class the other day that it was 1910, 1911 was the actual date where he wandered by a library, happened to open a book, talked about fossils, and looked at those that were on the continent of Africa and South America, and really decided to pursue this idea that the continents, were once must have been next to one another. Okay, so he is the person who is credited with proposing the idea that continents have moved and drifted apart. He's not the actual first person to think this, however, he's really the first person to give some evidence for this idea. And the picture here that I'm showing you is really showing you, what he thought, and that was this idea of a supercontinent called Pangaea existed 200 million years ago. And, again, his idea, continental drift, the continents drifted apart. Okay, so 135 million years ago, you have Pangaea. It broke up into two main land masses. The northern was Laurasia, the southern was Gondwana. 35 million years ago, again, you see more movement. These are starting to look similar to the continents that we see today. And then, of course, here is present day. And all the continents are in their proper place. And you can see some of the plate boundaries here in pink. Okay, and those represent the edges of the tectonic plates. Or these are the boundaries between the tectonic plates. Okay, so what was Wegener's hypothesis? Okay, he believed that the continents were once a single landmass which has since drifted apart. Again, so that idea of Pangaea. Pangaea means all lands. So this is what he thought was about 200 million years ago. I'm just going to scroll down and show you the whole picture again. Okay, again, what did he call this supercontinent? He named it Pangaea, which means all lands. So all of the continents were together as one giant supercontinent called Pangaea. Now let's discuss the evidence that Wegener had to support his theory. Again, we always talk about the shape of the continents, but it was really the fossils that made him really consider this idea that the continents were connected. After he studied fossils and found that, there were many that had two separate continents had the same type of fossils, and upon looking at more evidence, he also found that there were the same kinds of rocks present as well. Okay, which then led him to look at the shape of the continents. When we talk about that idea of a jigsaw puzzle, okay, I'm sure many of you guys have put those together, when you were little, recently, okay, and the idea that the pieces must fit together. Well, when Wagner looked at the shape of some of the continents, Africa and South America, really even today we can see after, hundreds of millions of years of erosion, the shape of those two continents still look like they could match up. Okay, and so that was a big piece of evidence. All right, so total, we're going to use the shape of the continents, okay, fossil evidence of climate change, and I'm going to explain what that means in a minute, and land features to support this theory. Okay, so that's what we're going to talk about, those features, with a little bit more detail. All right, so first let's look at the evidence from fossils. As I said, this was really the first thing that he saw and made him really think, oh wow, there are certain places where fossils are found on different continents but couldn't possibly have swam across the ocean. All right, so let's take a look at those. All right, and we say paleontological data, all right, basically means fossils. All right, and that same type of organism is found fossilized on many different continents. Okay, and so let's look at this picture. This shows you Australia, Antarctica, India, Africa, South America. Okay, and there are some freshwater reptiles called Mesosaurus and Lystrosaurus, okay, that are found, and if you look at the colored bands, that indicates that this organism was found, okay, in that area. Okay, you have another freshwater reptile located right here. Okay, another one in green. This is the fern. This is Glossopteris. Okay, and then this is the other reptile, and in the yellow band. Okay, so when you look at these organisms, okay, and you think about, the continents of South America and Africa, there is no way that these freshwater reptiles swam across the ocean, brought a mate with them, and then populated another continent. Okay, that just is impossible. Okay, there's no way, even floating on a log, the idea that they would survive the ocean voyage, in the hot sun without fresh water. Okay, I hope you understand that, that is just impossible. It did not happen. And the only explanation for these fossils to be found where they are, in this picture, is that these continents had to be touching. They had to be in a different place some point in the past, some place where they were all connected. Okay, so let's look at the evidence from climate. We call that paleoclimate data or ancient climate data. And what we see is that there are some areas where tropical plants are found in the fossil record, okay, but right now in the climate they are in currently, no way could it support it. For example, these are tropical plants that are found in Antarctica, or I should say tropical plant fossils that are found in Antarctica. Okay, now we know Antarctica cannot possibly support tropical plants or tropical animal fossils that are found there. Okay, there's just no way. Once again, the only explanation is that at some point in Antarctica's past, it was somewhere near the equator. Okay, because that's where we find tropical plants and animals. Okay, let's look at these glacial grooves. Okay, and these are striations you could see across the rock where the ice, as it pushed across the rock, made these grooves. There were sediment or, probably rocks, stones, pebbles at the bottom of the ice, and as that ice moved across this rock, it acted like sandpaper and just carved right into the bedrock. Okay, and these glacial grooves are found in South Africa. Okay, we know the climate of South Africa today. It definitely does not support a glacier. Okay, so again, the only explanation is that South Africa must have been somewhere colder in its past. Okay, so let's talk about the evidence from land features. Okay, and right here we're talking about the Appalachian Mountains here in the United States, found along the eastern coast. And then these are the eastern Greenland mountain range, okay, found up here. And that happens to match, if you look along the coast of Africa and the coast of Europe over here. Okay, and so what we see, that mountain chains in Africa and South America that line up as well, those are the brown located down here. And then we have this mountain range here. And again, if you understand how rocks are deposited, you would know that you cannot possibly have the same environment in the same place in two separate continents. Not to mention, these are the edges of the continents. You know, mountain ranges, you wouldn't expect to see that. The only way you could expect to see them is that if these continents plowed into each other and created that folding, you know, especially those folded mountains. Okay, we also have coal deposits in Europe and North America that line up. Okay, and so, you know, again, we find coal deposits, which requires a tropical climate, okay, in order for all that organic matter to be turned into coal, organic matter, tropical, lush vegetation, okay, and we find it in places that are not cold, or I'm sorry, that are not tropical today. You think about Pennsylvania and all the coal mines. Is that remotely tropical? No, it's not. So the only explanation is that at one point, okay, Pennsylvania was somewhere near the equator. Okay, so here, last part to this, and that is Alfred Wegener's problem. And the big problem was, and this is why geologists and you know, scientists around the world could not, you know, dig deep into his idea, is that he could not explain how the continents moved. He thought that the continents literally just plowed across the ocean floor like icebreaker does, you know, breaking up the ice in the water in the Arctic, okay? So he had no explanation for how those continents moved. He actually thought there was some sort of tidal force and centrifugal force, which, you know, other scientists definitely discredit those ideas. So unfortunately for him, he died before, you know, we actually explored the ocean floor and found some evidence that other things are going on the planet to, you know, really that totally agreed with Alfred Wegener and what he said, and it gave evidence for how the continents moved. Okay, and that's where we're going to go next. So please make sure that you get down all of the information. If you have questions, I need you to write those questions down, or you may email me, okay? So I know that you guys are doing this on your own today, but again, I need you to think about what I've been saying. I need you to, you know, ask questions. If you don't understand, you have to let me know, okay? Because what we're going to do next really builds on what, you know, Wegener's idea was, okay? So it's really important that you guys communicate with me, especially coming up here at the end of the semester. Okay, well, thanks for listening. Let's get everything on your note sheet, and you keep those because you need to study those. Have a good day, you guys. Bye.